Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 3, Measures of Central Tendency, brought to you by Vitan Sir. In the previous tutorial, I explained the discrete frequency and the continuous frequency sums based on the positional average median. Now in this tutorial, I am going to explain you the remaining three positional averages one by one and how to solve their sums. Starting with quartiles. Now what are quartiles? Quartiles are the values which divide the data into four equal parts. Quartiles are the quarters. Quarter means 1/4. So the data is divided into four equal parts. When it is arranged in ascending or descending order, these values are called quartiles. There are three quartiles because of course to divide the data into four parts we just need three values. Okay, you will just see how it is done. Assume that this is the line of data from 0 to 100, then this is the middlemost value and remaining two lines divide the whole data into four equal parts as you can see here. So these three lines divide the data into 25%, 25%, 25% and 25%. So the names of this line are Q1, Q2 and Q3. That means to divide the data into four parts, we need three values. Those are the quartiles, and the names of the quartiles are Q1, Q2, and Q3. Now, remember one other thing, that median is the middlemost value of the observation. That means it divides the data into two equal parts. So, which is the middlemost value in the quartiles? That is Q2. That means median is equal to Q2. Whether you calculate the median or you calculate the Q2, the meaning is same because median and Q2 both are the exact middle of the data. Let's move forward to the next. Second measure is the deciles. Deciles are the values which divide the data into 10 equal parts. Remember this, 10 equal parts. When the data is arranged in ascending or descending order, we call them deciles. Because the data is divided into 10 equal parts, we have 9 deciles, D1, D2 up to D9. Let us show the same data line here where there are 9 distinct lines dividing the data into 10 equal portions. The first line might be showing 10% data, the second line showing 20% data, the middlemost line shows the 50% data, and maybe the last line shows the 90% of the data as you can see here. So the names will be D1, D2, D5, D9. All the lines depict one of the deciles. So it is D1, D2, D3 up to D9. Now, as I explained in the last quartile, that the middlemost value of the observation is median, that is also Q2. So which is the middlemost value of the observation for a decile? That would be D5. That means median is equal to Q2, which is also equal to D5 because D5 is at the exact middle of the 100% observations. Moving on to a percentile. Percentiles are the values which divide the data into 100 equal parts. Percentile, percentage, 100 percentage. 100 equal parts when arranged in ascending or descending order, we call them the percentiles. Because the data is divided into 100 equal parts, there are 99 percentiles starting from P1, P2 up to P99. So quartiles are denoted by Q, deciles by D, and percentiles by P. Of course, I'm not going to show you the 99 lines here, but the same lines could be explained as 10%, 20%, 50%, 90%, and the 99%. The names will be, if it is a 10%, it is P10, of course. 20% is P20, 50% is P50, 90% is P90, and 99% is P99. Similarly, you can take it as P1, P2, P15, P17, P55, P65. You can take any value from P1 to P99. And the middlemost value of the percentile is P50. So remember this thing here, right here, it can be asked for a 1 mark, that median is equal to second quartile, that is equal to fifth decile, that is equal to 50th percentile. So remember this concept right here. Now I gave you a long list of formulas for calculating median. So what will be the formulas for calculating quartile, decile and percentile? Same as median, because median is a positional average and quartile, decile and percentiles are also the positional averages. There is no difference in their formulas, but a very small difference, and that small difference, the only difference is, how can I explain it? If we are calculating median, we divide the median by 2, whether it is n plus 1 or n, we divide it by 2. Why? I explained before, because the median divides the data into two equal parts. The observation is also divided by 2. So if the quartile divides the data by 4 parts, we will divide it by 4 and multiplying by the number of quartile. That means n plus 1, if observations are there, we will divide those observations by 4 and multiply it with the number of quartile. If it is a first quartile, multiply by 1. If it is a second quartile, multiply it by 2. And if it is a third quartile, it will be multiplied by 3. Similarly for decile, because it divides the data into 10 equal parts, divide it by 10 and multiply by number of decile. So n plus 1 or n observations will be divided by 10 multiplied by, if it is a first quartile, then first decile, then 1. If it is a second decile, then 2, and so on. Similarly for percentile, what we are going to do, divide by 100 and multiply with the number of percentile. It's always better to do the sum than to just look at the theory. So let's take two illustrations, very big illustrations, but nonetheless illustrations which will explain you how do we calculate quartile, decile and percentile, all the three. Illustration 25. Find Q1, D7 and P40 for the following data showing runs scored by a batsman in his 20 innings. The data is given, which is of course a quite haphazard data, not in an ascending or descending order. It is our responsibility to arrange the data into ascending order, because I always prefer the ascending order. Descending order is not actually required here. So I will arrange it in ascending order like this. 9, 10, 10, 14, 28, 29, 31, 32, 40, 47, 53, 54, 60, 62, 63, 67, 71, 80, 96 and 148. How many numbers are there? The innings are 20, so n will be 20. We are going to start by calculating the quartile, that is Q1. The formula is quite similar to median. The value of 1, because it is Q1, into n plus 1 divided by 4, because it is quartile observation. So when we solve this, it becomes 1 into 21 upon 4, but it is into 1, so I am not going to write down that multiplication of 1 here. 20 plus 1 upon 4th observation, that would be 21 upon 4th observation, making it 5.25th observation. Now 5.25th observation actually is not 5th observation, but after 5th. Now what comes after the 5th observation is the 6th observation. That means the data, the observation which we need is between the 5th observation and the 6th observation, but not exactly in between. If it would have been 5.5th observation, we would have just taken the average of 5th and 6th observations, but it is not possible here. So the thing which I am going to use here, remember this because it is used everywhere in the raw data and the discrete data, wherever we are doing this sum like this. For example, it is between 5th and the 6th observation. So 5th observation plus 0.25, 0.25 is the value by which 5th observation is behind. That means 5.25. So 5th observation plus 0.25 into bracket the observation after 5th, that is 6th observation, minus 5th observation. So this is how you are going to do the sum here. 5th observation, take it from the given ascending data, that is 28 into 0 plus 0.25. Sixth observation is 29, so 29 minus 28. Now go according to DMAS. First solve the bracket, then multiply it with 0.25 and then add it into the 28. So the data, the first quartile here is 28.25 runs. So the Q1 value of our data is 28.25 runs. Let's move forward. Let's move forward to the seventh decile. We have to follow the same manner. D7, that means 7 into n plus 1 divided by 10. Decile means divided by 10. Seventh decile means multiplied by 7. So 7 into 21, that is 20 plus 1 upon 10. 7 into 21 will be 147 divided by 10th observation, that would be 14.7th observation. We have to follow the same thing which we did in the last. 14.7th observation means 14th observation plus 0.7 into 15th observation minus 14th observation. This is the method of solving this kind of sums. 14th observation is 62, 15th observation is 63. So 62 plus 0.7 into 63 minus 62. That would be 62 plus 0.7 into 1. First multiply 1 with 0.7 and then add it into 62. So our seventh decile, the D7 value is 62.7 runs. Moving on along the same lines, finding the percentile, that is 40th percentile, P40. The value of 40 into n plus 1 upon 100th observation. Similarly, 40 into 20 plus 1 upon 100th observation. The value of 40 into 21 upon 100th observation. The value of 840 upon 100th observation, and when you divide it by 100 it becomes value of 8.4th observation. So 8th observation plus 0.4 into 9th minus 8th observation. Okay, so 8th observation is 32, 9th observation is 40. So 32 plus 0.4 into 40 minus 32. First solve the bracket, then multiply, then add the value. Your answer, the 40th percentile, is 35.2 runs. I hope you guys got the idea of how to solve this. This is just the raw data question. In the next question, I will be solving a quartile, decile and percentile sum of a continuous frequency distribution. Let us start with illustration 26. The following data refer to the milk quantity in 90 bags filled by a machine in a dairy. Find third quartile, second decile and 55th percentile from this data. The data is given in a table, the milk content in milliliters and number of bags, frequency, that's frequency. The class is given this like this, 485 to 490 and up to 505 to 510. The total, the bags are 5, 21, 33, 23, 8 and the total number of bags are 90. Now just like any continuous distribution, we need to find cumulative frequency for the calculation of positional average, any positional average. So the CF row will be 5 plus 21 26 plus 33 59 plus 23 82 plus 8 90. So the last value of CF must be equal to the total of frequency. If it is not, then you have made a mistake somewhere. Let us start with the third quartile class. Just like any continuous distribution for median, we have to start by calculating the class because we can't get the value directly. We don't have a variable here, we have the classes. So we have to start by determining the class here. The third quartile class will be very similar to the regular calculation. The class of 3n upon 4. Because this is a continuous distribution, we are not taking n plus 1, we are just taking n. Because it's a third quartile, multiplied by 3, and because it's a quartile, divided by 4. So 3 into 90 upon 4 will be 270 upon 4th observation, and the answer here will be 67.5th observation. Now let's see, where does this 67.5th observation lie in the CF? Can you see where 67.5th observation might be in? Yes, it's the CF82. So what is the class for CF82? The class for the CF82 where the 67.5th observation lie is 500 to 505. Now we have to find certain values, for example lower limit point, the frequency, the cumulative frequency of the previous class and the class length. So the lower limit of 500 to 505 is 500. The frequency is 23. The cumulative frequency before 82 is 59, and the class length of 500 to 505 is 5. Taking these values into consideration, we will start with our calculation of third quartile. L plus 3n upon 4 minus Cf upon F into C. Let's put the value into the equation. 500 plus 67.5 minus 59 upon 23 into 5. I have just put all the values here. That would give us 500 plus 8.5 upon 23 into 5. So 8.5 upon 23 into 5 is 1.85, and the answer will be 501.85 milliliters. Now I hope you guys remember that third quartile means that the 75% data is on the left side and 25% data is on the right side. That means if we are talking about milliliters of milk, the maximum milk is 501.85 milliliter in 75% bags with list milk. Okay, so the top 75% bags which has the list milk, that maximum milk amount is 501.85 ml. So Q3 tells us that the 75% data is less than this value. That means 75% of the bags fill less than 501.85 ml milk in it. I will start by writing down the data again here. It is just for your reference. You don't have to rewrite the whole table for each and every question. It is just so that you don't have to continuously rewind this video back to look at the data. Okay. So this is the data which we have. Now we are supposed to calculate the second decile class. That is, we are supposed to calculate second decile, and for that we need to calculate its class. Because it's the second decile, it will be 2n upon 10. That means 2 into 90 divided by 10. That is 180 divided by 10, getting us the answer of 18th observation. Now just look at the CF here. Where does the 18th observation lie? The 18th observation is included in the 26th CF 26, and the class for that is 490 to 495. So we can see from CF that the 18th observation lies in the class 490 to 495. So the lower limit point will be 490, the frequency 21, previous CF 5, and class length 5. So using this data, we will put the value in our second decile formula, that is L plus 2n upon 10 minus Cf upon F into C. Putting the values 490 plus 18 minus 5 upon 21 into 5. That would be 490 plus 13 upon 21 into 5. 13 upon 21 into 5 will get you 3.1, and your answer will be 493.1 ml. Because it's the second decile, that means 20% observations are less and 80% are more. So we can say that the maximum milk is 493.1 ml in 20% bags with list milk. That means at the second decile point, 20% bags fill milk less than 493.1 ml. Moving on to the last sum of this tutorial as well as this, I will be rewriting the whole table again in a fast manner. Speed up. We need to find the 55th percentile class here, that is 55 and upon 100th observation, meaning 55 will be multiplied by 90 and your answer will be 4950 divided by 100th observation, that is 49.5th observation. So as you can see from the CF, you can find that 49.5th observation is the part of the CF 59, and the class here is 495 to 500. So 49.5th observation lies in the class 495 to 500. The lower limit 495, frequency 33, previous CF 26, and the class length is same 5. Finding that P55 L plus 55 n upon 100 minus CF upon F into C. Putting the values 495 plus 49.5 minus 26 upon 33 into 5. When you solve the 49.5 minus 26, you get 23.5 into 5 upon 33. you will get 495 plus 3.56, and your answer here will be 498.56 ml. Now 55th percentile class basically means that 55% bags fill milk less than this value. So the maximum milk is 498.56 ml in 55% bags with list milk. Okay, so I hope you guys got the gist of the remaining positional averages, that is quartile, decile and percentiles. I also showed you the raw data and the continuous data. In the next tutorial I will be discussing the remaining sums, and maybe I will start with exercise, I don't know, depending on the time that is available with me. But in any case, in any doubts, just contact me or put a comment in the video below and I will see what I can do about it. Thank you for watching and I will catch you in the next video. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.